Hello Chemistry. This lab goes along with the Titration lab, which you will find in your lab tab in OneNote. You need to follow along with the lab and record this data either in your lab notebook if you have it, or on a piece of paper, or in OneNote if you don't have it. So to start off with this lab, we're going to go over the parts of a titration setup. Right, this big long tube here is called a burette. It has a jet tip at the bottom, and this is the stopcock here that controls the flow of whatever liquid we have in here as we add it down here to what we call the titrant. Okay? All right, so this is our setup in diagram form. You can see that I've loaded 2 molar sodium hydroxide into the burette here. This is a strong base, and we have 75 milliliters of HCl, a strong acid, down here. But the question that we will answer for this lab is, what is the molarity of this unknown acid? Okay, and this is the setup to do this. All right, so our goal here is to neutralize this unknown acid with the known base. What do I mean by known base? Well, it's 2 molar, right? We know that. All right, so to get started, we need a pH indicator. We've chosen phenolphthalein here. We're going to add just a few drops of phenolphthalein. Okay, plenty. Now, it doesn't change the color of the acidic solution. That's okay. All right, I'm going to just kind of swirl it up, get it nice and mixed. All right, that's because phenolphthalein is clear in acids, but it is pink in base. So our goal here will be to add this solution to the beaker down below until the color changes, okay? So we're going to do this very, very slowly and carefully by adjusting the stopcock till we get just a very slow drip coming from the jet tip. All right, so we turn it. Oh, before we do that, I forgot to tell you, we need to record the initial volume in our burette, right? And this is it right here. We're at 1.4 milliliters up here at the top. Burette is kind of funny because it goes from 0 at the top here to a reading of 50 down below. So it's almost like an inverted scale here because it's measuring the volume of whatever it is here that we add down below. So as this volume drops, the number will increase, and we'll talk about how we get our volume of base used there. But it's important to write down that initial volume before you get started. Okay, let's go ahead and start doing our drips. You want to be very careful here. There we go. And so this kind of experiment here, right, it's important to not go too fast. If you go too fast in this type of experiment, you can overshoot the neutralization point and it will look like you've used too much base, right? And that will throw off your calculations. So we want to make sure we're going slowly here. It can take a little bit of time as we do this, but it's more important to get a good answer. So we're going to do this here, and I'm going to swirl it, I guess, over and over again, right? That's just to mix it up and make sure that the acid and base are thoroughly reacted down in the beaker below. All right. I've gone ahead and cut a little bit of the video. We've added just about 20 milliliters right now. And so I just kind of fast forward a little bit to this point. Hopefully you can see on the video that we're starting to make a little bit of pink with every drop here. That's an indicator that we're getting somewhat close to the end point of the titration. The end point of the titration is when the neutralization process is complete. We want to make sure we hit the solution exactly when it turns pink. We don't want any extra drops, right? And so that's why we go slow. That's why we mix here to make sure we get right to the end point. So we're going to just kind of continue to do this, keep adding our drops, and see what we get. All right, guys, so we've added to just a little over 30 here, and I can tell from the way the color is changing that we're very close to the end point here of our titration. We went from 1 all the way down to here. So I'm going to go very slowly now with the drops, and not so slowly there. All right, and let's hope, yeah, that was a little too much. We're lucky it didn't turn pink there. All right, we're gonna go very slowly and hope that we can get right on the end point of our titration here. We want it to stay pink, but we don't want it to be a bright pink. We want it to be kind of a lightish pink color. If we get that, then we've just barely neutralized the solution. All right. If we get it to where it goes very hot pink, then that's a key indicator that we've overshot the end point of the titration. You'll hear those words kind of throughout the lab: endpoint, neutralization point, there's another one, equivalence point. All of these things mean that the moles of acid in our original container here are equal to the number of moles that we've added from the burette. All right, so we're just gonna, so if you see here, every drop gets us very close. It's taking more and more time in between drops for it to stop being pink here. So that means, what that means is that we're very close to the equivalence point. All right? We're very close now. Let's see. No, see, it's still going away like that when I swirl it. That means we're not quite there, but we want to go very slowly here so we don't overshoot the end point of the titration. One extra drop there. Oh, so close. See, almost stayed pink. We are very close to the end. Let's see. Are we going to stay pink? There we go. All right, so now, hopefully you see this, right? This is kind of the lightish pink color here that we get when we have changed from an acid to a base solution. So that means this is the end point of the titration here. The reading that we need is from the burette. And if I look here, right, before we started at 1.4 milliliters, right? And we went all the way down to, it looks to me like 34 milliliters exactly. Okay, we went all the way down, and now we're sitting down here at 34 milliliters. All right, so this was our initial, and this is our final volume readings from the burette. You should be able to calculate the volume here that we used, right? And then use the molarity formula to come up with the moles of base. Equate that to the moles of acid here in the original, and then come up with the final concentration here. All right, that's the goal of this experiment. Good luck. If you have questions, let me know.